So for this first problem on the review, we said to write the explicit formula in function form, and they gave us over here a sub n is equal to 5 plus 0.2 n minus 1, and then we have to fill it out. I'm going to annotate, and let me rewrite this so I have space. Okay, so when you are rewriting this in function form, you want to take the 0.2 or whatever number is outside of your parentheses, and you want to distribute it by multiplying it to everything inside the parentheses. So we have a sub n is equal to 5 plus 0.2 times n is just 0.2n, and then 0.2 times negative 1 would be minus 0.2. So all I did now was I just distributed everything to the inside the parentheses. Okay, give me one moment. Let's accept someone out of the waiting room. Okay, so then we need to combine like terms. So let me write a sub n is equal to, we're going to keep the 0.2 in the front, 0.2n over there, and then I want you to combine the 5 and then negative 0.2. So what is 5 minus 0.2? That would be plus 4.8. So this would be your answer, 0.2n plus 4.8. Well, and of course, they want you to replace the a sub n with f of n. So instead of a sub n, it's just f of n is equal to 0.2n plus 4.8. So this is your answer, and I'm going to go type it in. They already have the f of n is equal to, so I'm just going to type 0.2n plus 4.8. There we go. So that's the first one. And then for the y-intercept, you guys should remember from like the y equals mx plus b that the y-intercept is the b. So in this case, we have f of n instead of a y, but that's okay. It's the same thing. Is equal to 0.2n instead of mx, but that's the same thing because this is the one with the variable. And then we have plus 4.8. So then the y-intercept of the function will be this value, the 4.8. And you would write this as 0 for the x, comma 4.8 as the y, because this is your y-intercept, so the y value should be 4.8. So then I would type in 0, comma 4.8. 0, 4.8. Let me type. Please let me type. There we go. I don't know why I wasn't letting me type earlier. Here we go. So here's the answer for the first one. Do you guys have any questions? Okay. So always feel free to let me know if you do have any questions, and then I will check it out. It says 4.8, not 1.8, because 5 minus 0.2 will give us 4.8. That's where the numbers came from. 5 and then negative 0.2 gives us the 4.8. Okay, clearing all the drawings now. The answer is right here still, but we're going to go next. Number 2, consider the graph below. What is the equation of the line in slope-intercept form? Okay, so ignoring the options there, but let's just write the equation out together. So essentially we have the y equals mx plus b format. And remember we said just now that b is the y-intercept. Okay, so where does our graph touch the y-axis? It says -8. So I know I want a -8 over here. How do I know it's -8? Because it says so right there, where it touches the y-axis. So the y-intercept should be -8. Let's fill in the rest. Over here for our m is the slope. The slope is on the triangle, on the line, you can count from like one point to another, and you can see that we go up 1, right 1. So slope is rise over run. So if we go up 1, that's a rise of positive 1. We run to the right 1, so that is a run of positive 1. So 1 divided by 1 is 1. So our m value is 1. The x just stays there. So our equation should be y is equal to 1x minus 8. But wait, there's more. You want to simplify this because 1x is the same thing as x. So y is equal to x minus 8 should be our final answer. So let's go take a look and find this on our thing. That's right here. It's answer B. Okay, so we want answer B. Any questions on this one? Okay. Remember, if you do have a question, feel free to ask me. Okay, so why the ones? Look over here at the slope triangle that we drew. So from one point to another, you go up 1. That's why we had a 1. And then you go right 1. That's why we have another 1. So rise is the up down. Run is the left right. And since we went up 1, that's a rise of 1. And we went right 1, that is a run of 1. Okay. Any more questions? Okay, let's go on to the next problem then. Okay, consider the tables of values shown below. We have two tables. Determine whether each table of values represents a linear function. For those that do not, explain why not. Okay, so for this one, I want us to go take a look at Desmos. If we have a linear function, I'm trying to highlight it, but I can't. If we have a linear function, you should have a straight line. Your dots should make a straight line. Let's take a look if we can make a straight line out of this. So I'm going to, let's see, oops. Let's do that. Okay. I'm going to add a table. We've done this before. We've made a table. -2, 0, 2, 4. -7, -6, -5, -4. Okay, look at those dots. Do they make a straight line? Yes, table M represents a linear function because the dots make a straight line. When I entered the table values in here, they made a straight line. And so, therefore, it is a linear function because the dots are in a straight line. Table M is a linear function because the points form a straight line. Let's take a look at table N. So I'm going to type in for table N now. Let's see over here. Add table, table. So now we're going to look at the points in, what color should I pick? Let's pick purple. Okay, so we have -2, -1, 0, 1. This one goes from 10, 6, 4, 2. Okay, are these in a straight line? No, look at that one. Look at this point all the way up here. This one, it kind of bends upwards more. It's not a straight line anymore. So then table N, this purple one, these purple dots, table N is not a linear function because the points do not form a straight line. Also, somebody asked me if I will be posting this video later on. Of course I will. Okay. Finally, let's go to the last question. Part B says, write the function for the values in the table that represent the linear function. Okay, so we're going to write a function for the green dots. Okay, so let me clear out these purple dots. We don't need to look at them anymore. We want to write a function for these green dots. So there are a few ways that you can approach this. You can do it from the graph, or you can do it from the table. So I'm going to show you, well, I'll show you from the graph because I think visuals are nice. Okay, so from the graph, if we have this straight line that goes through these points, and we want to write it in the y equals mx plus b format. Wait, actually, let me scroll down now. Okay, there we go. Or technically, f of x, because they want f of x over here, f of x is equal to mx plus b. So since we want it in this format, let's first figure out our y-intercept. Where do we touch the y-axis? And you can see on the graph it's at -6. You can also see on the table it's at -6. Okay, so if you wanted to do it from the table, look next to where your x is 0. You see the y value is -6, so I know our b is -6. Okay, and then we need to figure out the m, the slope. M is the slope. So on the graph, you can go from one point to another. And then remember, rise over run. So how much did we go up? We went up by 1. So it's a rise of 1. And a run of, how much did we go to the right? 2. So 1 over 2 is our m. 1 over 2 x is part of the equation. So your equation is f of x is equal to 1/2 x minus 6. If you were to do this from the graph, what you could do is pick two sets of points, any two sets of points, and you would calculate the rise from the y values. So how much do you go up here? From -5 to -4, you can subtract -4 minus -5. And then, let's see what that equals. That equals -4 plus 5. This will equal 1. So that's your rise. And then if you calculate your run, that's over here, how much do you go up? So you do 4 minus 2, that equals 2. This is your run. So you can see we still get the same rise and run as we got over here. Rise and run was 1 over 2. Now when you get it from the table, you still get a rise of 1 and you still get a run of 2. So when you put it together, it's still 1/2. Either way, you would get the same answer. And the 1/2 goes to replace the m value. So your final answer is 1/2 x minus 6. I'm going to go type that in now. There we go. Any questions on this? Okay. Let's clear our drawings and go to the next one. An elevator in a high-rise building moves upward at a constant rate. The table shows the height of the elevator and ground after various times. Determine the average rate of change for the situation with the correct unit. So let's annotate. Okay, so the rate of change is the slope. So we're going to pick any 2 points. I'm just going to choose those 2 because why not? And remember the slope formula, y2 minus y1 over x2 minus x1. So this one would be your y2, this is your y1, this is your x2, this is your x1. We're going to do 48 minus 36 over 4 minus 3. Literally the same thing that we just used in the last problem. So 48 minus 36 is 12. 4 minus 3 is 1. So 12 divided by 1 is 12. So our average rate of change is 12. So I'm going to go enter that in over here. 12. But 12 what? What are we even talking about? We divided height, which is in feet, by seconds. So it's feet divided by seconds. Y divided by x. see, y divided by x. So we have the feet divided by the seconds, so it's feet per seconds. Oops, I gotta scroll. Feet per second. Okay, so feet per second. Do you guys have any questions? Okay. All right, let's scroll down to do the next one. Clear all drawings. The function that models a table of values is, and then they want us to write the table of, write the equation. All right, so let me annotate again. We just determined that the, hold on. Okay, so we just determined that the average rate of change was 12 feet per second. So we know that f of t is equal to, why am I using t? Because they want us to, okay? F of t is equal to 12t, and then we need to figure out our b value. We don't know our b value yet, but we can figure it out by plugging in any point. So you can pick this point, or you can pick this point, but I'm just gonna pick this one because why not? So this is your t value, and this is your f of t value. So we have 48 is equal to 12 times 4 plus b. So we need to solve for b. And all I did right now was I plugged in this point into our equation. So 48 replaced the f of t, and then the 4 replaced the t. So we have 48 is equal to, what is 12 times 4? That's 48. And then plus b. Then we subtract 48 so we can get b all by itself. And we get 0 is equal to b. So finally, we can rewrite this equation with the actual b value. F of t is equal to 12t plus b, and we just said our b was 0. So it's 12t plus 0. So I'm going to go type that in to over here. 12t plus 0. And once again, for the third time, yes, I will post this recording on the Google Classroom. Well, not on the Google Classroom, on the website. But yes, the recording will be posted. I always post the recordings. Yes. Okay, where t is the, okay, so we need to figure out what t is. So I'm going to scroll up. T is the time in seconds, okay? T stands for time in seconds. And f of t is the, what do you think f of t stands for? Height in feet. And we get that straight from the t table right over here. Height in feet is the f of t, and time in seconds is the t. Okay, part C says determine the height in feet of the elevator at 14 seconds. So that means we need to plug in 14 to our equation. So here's our equation. So I'm going to plug in 14 now. F of 14, that means I'm plugging in 14, is equal to 12 times 14 plus 0. So you can use a calculator on this. What is 12 times 14? Let's take a look. And I get 168. So F of 14 is equal to 168 plus 0. Remember, I didn't add 0 yet, but that's the same thing. So 168 plus 0 is just 168. So the height in feet of the elevator at 14 seconds is 168 feet. And I'm going to go type that in now. Okay, are there any questions? Okay. So it looks like there are no questions. So if not, then I'm going to clear the annotations and we're going to go to the next one. Next. Okay, suppose an elevator starts at the top floor of a high-rise building at a height of 450 feet above the ground and descends without stopping at a constant rate of 15 feet per second. Write a function that describes the height of the elevator after t seconds in both general and factored form. So this one, oops, here, let me do some annotation first. Remember that if they want h of t, I'm going to use h of t. So we want t plus b. The m is the rate of change, and we are descending without stopping at a constant rate of 15 feet per second. So it's going to be 15. But wait, we are descending. So we're going down, so it should be a negative 15. And then we have the t here, and then plus b. B is the y-intercept, also known as the starting value. How high did we start above the ground? 450 feet above the ground, so it should be plus 450. So h of t should be equal to negative 15t plus 450. And so that's what we're going to write in this general form right over here. Negative 15t plus 450. Okay, so that is our general form. Any questions so far? Okay. Remember that you can always ask me if you guys have any questions. The next part is the factored form. So from the notes, we know that to get factored form, you want to divide the negative 15 out from both of these terms. So negative 15. If we take the negative 15 away from the negative 15t, we will be left with t. And then the last bit is, what is 450 divided by negative 15? 450 divided by negative 15. I'm going to type this on my calculator. 450 divided by negative 15. That will give me negative 30. So this would be our factored form. How did I get the negative 30? I divided 450, this number, I divided it by negative 15. So then that gave me 30, negative 30. So this is our factored form, and I'm going to type it in, and then I'll give you guys a chance to see if you have any questions. Okay, any questions? Wouldn't I need to divide negative 15 by negative 15 also? So I divided negative, oops, I'm not annotating, give me a second. I divided the negative 15t by negative 15. And so when you divide that out, yes, you get 1t, which is the same thing as just regular t over here. So yes, you are right. We did need to divide the negative 15t by the negative 15. And that's what we did. When you divide negative 15t by negative 15, you get 1t over here. So that's why there's 1t over here. But 1t is the same as t, so that's why we just write it as t. Good question. Any other questions? Okay, let's clear this drawing and then we can go to the next question. Okay, so for this one, it says, suppose an elevator, so many elevators. Suppose an elevator starts at the top floor of a high-rise building at a height of 450 feet above the ground and descends without stopping at a constant rate of 15 feet per second. So essentially the problem that we just did. Graph the function that describes the height h of the elevator after t seconds. So we want to add a point. So you have to click points, I believe. And then we start off at 450. So that's where we start. And then we descend at a constant rate of 15 feet per second. Let me see, what did we calculate in the last one? Oh, we just wrote the equation, huh? Okay. So let's see. Let me write it out. Sorry, there's a lot of things I have to toggle, like the annotation. Oh, wait, hold on. Let me scroll down more first. There we go. Okay, so the equation we wrote was f of t is equal to 450. No, it was equal to negative 15t plus 450. There we go. This was the equation we just wrote in the last problem. And so let's plug in one of these points from the x-axis so we can see what numbers come out of it so we can find out another point to plot. We can plug in 30. Let's see what happens there. F of 30 is equal to negative 15 times 30 plus 450. What happens here? So take out your calculator and you can do negative 15 times 30 and you'll get negative 450 plus 450. And so when you simplify this, you get 0 because negative 450 plus 450 equals 0. What this means is that there is a point where if your t value is 30, your y value would be 0. So this is the next point we can plot. So let me go point that out. There we go. So that's our point, 30, 0. And then we can connect it with a line. Oh, just kidding. How do I draw the line? Click, click. There we go. So if you just click the line button, then you just click, click at the 2 points, and then you will draw a line through there. So this is the line you guys should have for number 6. Do you guys have any questions? Okay, so remember, if you do have a question, just let me know. Meanwhile, I'm going to clear the annotation. Let me scroll down to make sure there's nothing underneath. Or actually, I could just scroll like that. Okay, no, there's nothing underneath. So let's go on to the next problem then. Number 17, the same elevator problem. If the vertical axis represents height in feet and the horizontal axis represents time in seconds, what do the x and y intercepts explain in the context? So essentially what they're saying is, what does this point even mean, this 450? And also, what does this 30 mean also? So for the height of 450, that's where we started, right? I'm trying to see if I can highlight this. Nope, I can't. Okay, so our elevator starts at a height of 450 feet. That's why we have a y-intercept at 450 feet. So I'm going to type that. The y-intercept at 0, 450 means that the elevator starts at a height of 450 feet. It's important that you use the units, so I say 450 feet. I don't just say starts at a height of 450. 450 what? Inches? Feet? Yards? Meters? It is feet, okay, because they tell us it is in feet. So the y-intercept is the starting height of 450 feet. Now let's take a look at the x-intercept. The x-intercept was at 30, 0. Let me just show you again in the picture. The x-intercept was over here where it touches the x-axis at 30, 0. So the x-intercept at 30, 0 means that the elevator reaches a height of 0 feet after 30 seconds. This is when the elevator touches the floor Okay, so if the height of the elevator is at 0 feet, that means the elevator is back on the floor now. So at 30, 0, that means the elevator is now on the ground. Are there any questions on this one? Okay, let's do the next one then. Consider the graph below. Complete the sentence. The value of f of x at 5 is, the value of f of x is 5 at x equals what? Okay, so they're looking for when is our graph going to be at the height of 5. So here's the height of 5. Oops, come on. Here's the height of 5. What x value is this point at? Because this is where our line will reach the height of 5. So what x value is this? This is an x value of -1. So the value of f of x, that's the y value. So the y is at 5 when x is -1. And then we also want to figure out the value of f of 5. So let me go annotate again. F of 5 is when our x value is 5. So where will our graph be over here? So if we were to continue this graph, we know that it goes down 2 and right 1, down 2, right 1 always. So then over here we would go down 2 and right 1, and this is where we would be. So when our x value is 5, what is our y value here? So we know that this is -5. Then if we went down more, -6, -7, because we go down 2 before we go right 1. And so if we went down 2, we would be at -7. Are there any questions on this one? We're almost done with this review. And then you guys can do review number 2. Okay, let's clear the annotations then. Next question. Fill in the table to find the value of the function blah, blah, blah at each of those values. So I'm not going to read that, but I will show you how to plug it in by writing it out. So on the first one, we are plugging in 6.2. So f of 6.2 is equal to 31.572 times 6.2 minus 17.741. So you're just going to have to type this on a calculator. Okay, so multiplying first and then subtracting. So 31.572 multiplied by 6.2. And then I want you to subtract 17.741. And that gives me 178.0054. So I'm going to go type that in. 178.0054. Okay, let's do the other one. We are plugging in -27.018. So that's going to be equal to 31.572 times -27.018 minus 17.741. So type that into a calculator. Remember to do the multiplication first. So 31.572 multiplied by -27.018. And then we're going to subtract 17.741. And this will give you -870.753. I'll just round it. They give me a lot of decimal places. So I'm going to type that, negative 870.7533. I have a question on how do I go to the website to find the video. The link to the website is in the Google Classroom. And the video will be posted after class because I'm recording it as we speak right now. Okay, any questions on this problem? Okay, let's clear the drawings and go to the next problem. Okay, so we are given another graph, and now we need a graph f of x plus 4. So these are the transformations. When you are adding 4 at the end of the equation, that means we are moving it up 4. Okay, so we want to move our graph up by 4 units. So originally, we had our y-intercept at -3, but we are going to move it up 4. So instead of at -3, we go up 1, 2, 3, 4. We should have a y-intercept at 1. So I'm putting that there. Okay, y-intercept at 1. And then our slope remains the same. Everything else is just going to shift up 4. So let's take a look at this point. When our x is 2, originally the x was at -2, but now we are going to move it up 4. 1, 2, 3, 4. We should now have a point at 2, positive 2. 2, positive 2, right over here. 2, positive 2. So I'm going to plot that. Oh, there it is. 2, positive 2. So now we have our 2 points. You may now connect them with a line. There we go. So all we did when we have f of x plus 4 is you want to make the graph shift upwards by 4. So now it's just up 4 from the original graph. Are there any questions? Okay, let's go to the next one. If you do have a question and you're just not typing fast enough, just send it over and we can always come back. Given the graph of f of x, now we're graphing 2 multiplied to f of x. So when it's being multiplied and not added, subtracted, that means we are going to multiply our y values. Okay? So originally, we have 0, -3 as our y-intercept. What is -3 multiplied by 2? -3 multiplied by 2, that would give us -6. So you have a point now at 0, -6 right over there. How do we get that? -6? Well, we take our original y value and you multiply it by 2. Okay, let's do another point. Over here we have 2, -2. We're going to take our original y value, which is -2. What is -2 multiplied by 2? -2 multiplied by 2, that should be -4. So I'm going to put my second point over here at 2, -4. We keep the original x value at 2, but we multiplied the y value by our scale factor over here. So we multiply this by this, and that gives us -4. Then you can connect it with a line. There we go. Any questions on this one? All right, I appreciate the students that are responding to me. Thank you. Let's go to the next one then. Find the slope of a line that passes through those points. Cool, so we're going to annotate and we're going to use our slope formula, which if you guys remember is y2 minus y1 over x2 minus x1. We are given these points. This can be our first point, so that's x1 and this is y1. Sorry, that's messy. Then this would be x2 and that would be y2. So plugging it in, our y2 is 8, minus our y1, which is 3, divided by our x2, negative 3, minus our x1, negative 5. Simplifying this, 8 minus 3 on the top is 5. On the bottom, we have a negative 3 minus a negative 5. This is really negative 3 plus 5, because when you subtract a negative, you are just adding the positive. So we have negative 3 plus 5 on the bottom. That gives us 2. And so our slope is 5 over 2, this first one. Do you guys have any questions on this one? Cool. Okay. So I'll leave it up a little bit longer so people can copy it. And then you can let me know when you're done copying it. Okay, let's clear the annotations and move to the next one. Okay, enter an expression in the box to write the equation of the line parallel to that equation that passes through the point -2, -3. So for this one, if we want a line that is parallel, that means you keep the same slope. So if I have y is equal to 4x plus 3, I'm going to keep the 4, and the 3, I'm just going to throw it away. So y is equal to 4x plus b. We're going to solve for b by plugging in this point. So here's our x, here's our y. Let's plug it in. The y is negative 3. The x is negative 2. And so there I have plugged in the point -2 comma -3 into our y is equal to 4x plus b. And now the only equation, or the only variable we have left, is b, and we get to solve for it. So we have -3 is equal to -8 plus b, because 4 times -2 is -8. And then to solve for b, we're going to add 8 on both sides to get the b by itself, which will give us -3 plus 8 is 5. And so 5 is equal to b. But we're not just going to enter the number 5 in here. Remember, we want to write the entire equation. Here was the start of our equation, and now we know what b is. So we're going to put that together. Y is equal to 4x plus, we now know our b is 5. So y is equal to 4x plus 5. We're going to be entering in the 4x plus 5 because they already have the y equals. See, y equals is already there. So I'm going to go type that in. 4x plus 5. Okay. All right, looks like we're ready to move on to the next one. So I'm going to clear this and go to the next one. Enter an expression in the box to write the equation of the line perpendicular to y is equal to -3x minus 1 that passes through the point 3, 4. So this time is very similar, except we have perpendicular. So when you have perpendicular, you want the negative, I'll just write it like that, reciprocal. I'll just write it like that. So instead of y is equal to -3x minus 1, this equation, our slope is -3 over 1. So let's first make it negative. So the opposites of -3 over 1, that's going to be +3 over 1, because now we just flip the sign. And then we want the reciprocal. So we reciprocate this, we're just going to flip it upside down, and now it's going to be 1/3. So the slope we want to use in our new equation is 1/3. Y is equal to 1/3 x plus b. So once again, when you want perpendicular, you want the negative reciprocal of the original slope. Our original slope was -3 over 1. We changed the sign so it's +3 over 1. And then we reciprocated it, which means we flipped it around, so now it's 1/3. So this is our perpendicular slope, 1/3. Any questions on that part? Okay, let's plug in this point. Remember that x is 3, y is 4, so then instead of y is equal to, I write 4 is equal to 1/3. Instead of the x, I write a 3 plus b. Let's solve for b. 4 is equal to 1/3 times 3. If you don't know how to do that, just type in the calculator. You will get 1. So 1 plus b, then you subtract 1 to solve for b. 3 is equal to b. So then we're going to write this out so that we can have our b value in our equation. Y is equal to 1/3 x. Instead of plus b now we know what b is. It's plus 3. So we're going to type 1/3 x plus 3 because I already have the y equals. So 1/3 x plus 3 over here. Any questions? Okay, let's do the last one. Okay, the last one. Use the functions f of x and g of x to compare the to complete the comparison statements using less than, greater than, or equal to. Okay, let me just annotate a little bit. This one means, oops, this is less than. This one is greater than. Okay, so if you don't remember it, that's something you should write down so that you can remember it for later on. Okay, so here's f of x. I know it's very tiny, it's hard to see. And this one's g of x. Okay, we're going to compare, on the first comparison statement, we're comparing f of 5 and g of 5. Let's figure out what f of 5 is. F of 5, when we're plugging it into our f of x equation, is negative x minus 5. So negative 5 minus 5. So f of 5 is equal to negative 5 minus 5, which is negative 10. So we have negative 10 for f of 5. G of 5 is where you see right over here where our x value is 5 on our g of x table. And you can see that we have a g of 5 or g of x value of 3. So we are comparing negative 10 and 3. So negative 10 is less than 3. So I'm going to write the less than symbol. Do you guys have any questions on that one? So for the equation, we get our answer by plugging it in. That's how we did this one. And then for the table, you just look for the x value over here. We found the 5, and that means the y value is 3. So we compare those two. Negative 10 is less than 3. Okay, I'm going to do the next one in a different color just so that you don't get confused with all the extra work. Okay, so the slope of f and the slope of g, let's compare those. So the slope of f is straightforward from the equation because it's just the coefficient in front of the x. So I see a negative sign, that means our slope is a negative 1. So I'm going to write that here. Our slope of f is negative 1. That's straight from the equation. Right in front of the x is a negative symbol. There's no number, but it's an invisible 1. So it's negative 1 is the slope of f of x. So to get the slope of g of x, you have to choose a set of points. I'll just choose those two, and then you label them y2, y1, x2, x1, and we plug it into this formula. We plug it into the average rate of change formula. We plug it into the slope formula. So we have negative 17 minus negative 27 all over negative 5 minus negative 10. So remember, when you are subtracting a negative, like we are doing in both of these cases, that's the same as adding. So negative 17 plus 27, and then negative 5 plus 10. And then that simplifies to 2. 10 divided by 5 is 2. So our slope for G is 2. So we have to compare, is negative 1 less than 2, greater than 2, or equal to 2? Negative 1 is less than 2. Are there any questions on the purple example? How did I get the 1? Oh, the negative 1? Yeah. Okay, so once again, over here is our equation, right? And the slope has to be the number in front of x. So in front of x, all you see is a negative symbol, which means there's an invisible 1 there. So it's a negative 1x, because f of x is equal to negative x minus 5 is the exact same thing as f of x is equal to negative 1x minus 5. So even though I didn't write the 1 in this equation over here, just know that if you don't see a number there and it's being multiplied, that means it's a negative 1. So that's why we got the negative 1 over here. Okay, good question. Any other questions? Okay, let's do the last one in blue so that you guys don't get confused with all the stuff going on. Okay, so the blue's comparing the y-intercept. So the y-intercept's easy on the equation because you just have to look at what's being added or subtracted in the end. So if you look at either of those equation versions that I wrote, we know that the y-intercept is negative 5 because it's just minus 5 at the end. So negative 5 is the y-intercept of f. Then to get the y-intercept of G, you have to look for where is your x value 0 on the t-table. Where is the x value 0 on the t-table? Then you can see that the y-intercept is negative 7. Because when you are on the y-intercept, you are on the y-axis. Every point on the y-axis has an x value of 0. If you were to plot this out, this would be where it touches your y-axis. So that would be your y-intercept is negative 7 on the t-table. So we have negative 5 and negative 7, and we need to compare them. Which one is bigger? Negative 5 is bigger than negative 7. Because you'd rather owe someone $5 than owe them $7. So negative 5 is bigger than negative 7. Are there any questions on this one? Okay. I'm not going to clear the drawings yet. I'm just going to enter the stuff in. So the less than, and the greater than. Okay. Final time. Are there any questions on this one? Okie dokie. Let's clear all drawings then. Or actually, does anybody still need to write? Why is the first both negatives? Why is the first? You mean the blue one? Negative 5. Why is the y-intercept negative 5? Because in the equation, it's negative x minus 5, like right over here. So since it's not plus 5, it has to be a negative number. Oh, the first step. Oh, I think. Do you mean right over here? Wait, you said okay. So the green example. You're asking about the green example? Oh, okay. Why is that one? Okay. Let me do this in green because I want it to be in green. Okay. So this one is -5 because our equation right over here, I'm going to rewrite our equation out. F of x is equal to -x minus 5. So if I'm plugging in 5, then our x gets replaced by 5. The x gets replaced by 5. The negative has to still be there. This negative is not like the x value. This negative is part of the equation, so it still needs to be here. That's why it's -5. Okay. Did that answer your question? Okay, you're welcome. Any other questions? Alrighty, sounds like a no. I'm gonna clear all drawings now, and then I'll end the recording. Well, I mean, I need to submit it first. I don't think it'll show a score. So it shows a score, but it's also some need to be like manually graded. Like this one needs to be manually graded because it's writing. See? Some of these just need to be manually graded. So yeah. Oh, did we not enter this one? Oh, I think we accidentally skipped a question. Oh, I don't want to skip a question. I want to like show you guys how to do that. I didn't even know that I didn't I didn't know that I skipped it. Sorry. Let's annotate and let's do this problem together. I mean, you can see the correct answer already, but I just want to make sure you know how to get there. Okay, so it's the same elevator problem that we were doing like the entire time, but we want to determine at what time in seconds the elevator will be at 210 feet above the ground floor. This is after we already got the equation for the elevator, isn't it? Yes, so we know the equation is -15t plus 450. Let me write that out. Okay, so we know the equation, and then we want to know when the height will be at 210 feet. So the height is right over here, the h of t. So we are going to need to solve for t. So we have 210 is equal to -15t plus 450. We're going to minus 450. So 210 minus 450. And that gives us -240 equals -15t. And then those are being multiplied, so you got to divide to cancel. Divide to cancel. And if you do -240 divided by -15, you'll get 16 as your answer. So the answer is 16 seconds, which I would have shown you, but I guess I accidentally double-clicked the next button and then I skipped over it. My bad. Any questions on this one? All right. Once again, I appreciate those who are answering in the chat. Can I show number 7 again? Okay. Let me scroll through the rest first so I can end the recording and then I'll show you 7. Okay, let's scroll through the rest, make sure I didn't skip anything. Okay, didn't skip that. Oops. Okay, I rounded it and I guess apparently don't round it. I'll fix this if this happens on the test though. See how I rounded it, just I cut off the last 2 numbers? I guess don't do that. But I'll fix that if that happened to you guys, okay? This one's fine, 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 everything's fine. I don't know what happened here because you can see the correct answers are literally those. But I'll fix that when it happens to you guys, okay? All right, and that was the whole thing. So let me stop share or let me end the recording so that I can show you number 7 again.